So now we want to know, will it dissolve or not? So when we talk about is something going to dissolve or not, we're going to refer of the solubility. So this solubility is telling me if something is soluble or not. Will it dissolve? So soluble are compounds that dissolve in a solvent. It doesn't necessarily have to mean that it dissolves in water. That would be aqueous specifically. So if I say something is soluble, then I would have to say like NaCl is soluble in water. So I would have to say what is the compound, what is the solute that I'm referring to being soluble, and what is it soluble in. So I have to name the compound and the solvent. So if it will dissolve, it's soluble in that solvent. If it's insoluble, then these are compounds that do not dissolve in a solvent. So how do I figure out if it's going to dissolve or not? So the way that I have to figure out if it's soluble or insoluble is based on the formula. So I can look at the molecular formula of the compound and then figure it out from that. And I'll show you how we have rules for that. But there's one thing that actually affects the solubility. So say you're making sweet tea and you want it to be really, really sweet. When do you want to put in the sugar? Do you want to put in the sugar when it's hot or when it's cold? Usually you want to put it in when it's hot, right? Well, why? So usually it's because the reason you want to put it in when it's hot is because it will actually dissolve more of the sugar than when it's cold. So my solubility is temperature dependent. Now I can't take something insoluble, heat it up, and make it all of a sudden soluble. What I can do is change how much it will dissolve. So the degree of solubility depends on the temperature. So the degree of solubility depends on the temperature. So then how do I know, how did we figure this out? How do we know which compounds were soluble and which ones were insoluble? So back in the day, the thing that they did to figure this out is called the empirical method. So they used what's called the empirical method. And the empirical method is just a fancy term for it. They tried a bunch of stuff, dumped stuff in, dumped some stuff in some other solvents, tried a bunch of options, and recognized that there were patterns and trends based on what they were dissolving in. So they just pretty much trial and error, okay? So this is a fancy word for trial and error, pretty much. So you do some experiments, and you observe patterns. And when you observe these patterns, you can develop some rules. So now we're going to have rules that will help us to be able to predict if something's going to be soluble or insoluble. But these rules were only established by people just trying it out and seeing what worked and what didn't work. So you're going to have two tables. Now, this is important because it's not like all things can be determined from these two tables. The first thing we have to note is that this is tables for water. Okay? So this is assuming we're dumping anything into water. If it's not water, then you have to go get another table. So there's a big book of a bunch of tables because we have a bunch of different solvents. Okay? So this is talking about things that are soluble. So I want us to compare this chart and the next chart. So both of these charts are for water, so we're talking about dissolving something in water. This chart is talking about things that are going to be soluble. So what kind of things will be soluble, where the next thing is saying what things are generally insoluble. So you need to make sure that when you're reading the chart, you're reading it the correct way. So what this is telling me is that if I have something with a lithium ion, a lithium plus cation, then it's going to always be soluble. There's no exceptions to this. This is saying if I have a chlorine anion, then it's going to be soluble unless it is with one of these cations. If it's one of those cations, now it's going to be insoluble. Okay, so this chart is talking about what's generally soluble. This chart is saying, okay, if I have OH minus, he's generally insoluble unless he's attached to one of these guys. If he's with lithium, then he's now soluble. If he's with calcium, then he's slightly soluble. Okay, so that's how I can look at a compound and know if it's going to be soluble or insoluble based on what those ions. So it's important to be able to look at a molecule and break it apart into its ions. We're going to use this table more in the rest of this chapter, so you want to make sure you can flip to it and look at it. So to talk about solubility, we're going to talk about a very specific type of reaction that helps us when we're using our solubility rules. And that's going to be a precipitation reaction. And I'll talk about precipitation reactions a little bit more in the next lecture.